Hello class, in this lesson we're going to learn how to find unknown side lengths of right triangles. First, as a warm-up, I'd like you to write down the definitions of the three basic trigonometric ratios: sine, cosine, and tangent. Let's take a moment on that, and I'll show you the answers. So here we have the three definitions, along with the mnemonic SOHCAHTOA. You have to have this memorized. They're not going to give it to you on any state tests, so you got to have this in the back of your head. Now, we already learned how to write these ratios in the previous lesson, but how are they useful? Why are we learning this? Well, they're really useful in indirect measurements. So let's look at an example. Here, we have a person, Serena, and she knows the angle of elevation here, 41 degrees, to the top of the building. And she also knows how far away she is from the building, 120 meters. Using this information, we can figure out how tall the building is and how far away she is from the top of it. Now, those are two things that are going to be relatively hard to calculate. So instead, indirect measurement with trigonometry is going to be easier. So how do we go about this? Well, first thing you do is you label your three sides like we've been doing. So here's our angle. The adjacent leg is over here. Opposite leg is over here, the height of the building. And the hypotenuse is this distance. So now the question is, which of the three ratios is going to be useful? Well, first, let's find the height of the building. So we're looking for the height of the building. We're going to use the opposite leg. So we have to use a ratio that contains opposite. So we can't use cosine here. And we know the length of the adjacent leg. So we have to have an adjacent in our ratio. So we can't use sine. So here we're going to use tangent. So the tangent of 41 degrees equals opposite over adjacent. Now we can fill in those blanks. We know the opposite length is y, and the adjacent is 120. Now, how do we solve this? Well, we know that tangent is just a ratio. It's just a number. So we can solve this just like we did in algebra. How would you solve this? You could apply the cross products. Or just think of the opposite of dividing by 120, multiply by 120. So if we multiply both sides here by 120, we get y equals 120 times the tangent of 41 degrees. Now, how do we figure out what the tangent of 41 degrees is? Well, thankfully, our graphing calculator will do that for us. So in order to do this, first double check that your calculator is in degree mode. To do so, press the mode button. Go down to where it says radian. Go to the right and press enter. And now degree is highlighted, so we're in the correct mode. So tangent of 41 is just a number. And it's about this number. Now, you can put that down as a step and then multiply, but sometimes you'll make a mistake in copying the number or in rounding. So what I like to do is I just put this entire expression in the calculator and then write down the answer. So while tangent of 41 is about that number, we get a more precise answer and less prone to making errors if we just put 120 times the tangent of 41 degrees in the calculator. And we get about 104 meters for the height of the building. We're going to do the same, a similar process to figure out this distance, length by hypotenuse. While it's true that we could use Pythagorean theorem, we rounded our answer, and it's a really long decimal, so it's really better in this case if we just use trigonometry. Either way is correct, but I prefer to just use the 120 meters that we have here. So to figure out how long the hypotenuse is, we're going to use hypotenuse, so we can't use tangent. Well, it's opposite and adjacent, and we know the adjacent length. So we're going to use cosine because that has adjacent and hypotenuse. So cosine of 41 degrees is adjacent over hypotenuse, which is 120 over z. And you can solve this. I like to think of it as switching the extremes in a proportion. So you switch where the z and the cosine of 41 degrees are. And this is 120 divided by cosine of 41 degrees. So you put this in the calculator, divided by cosine of 41. It's a good habit to close your parentheses after using the trigonometric function here. About 159 meters. So once again, I like to skip the step in the middle, but I want to show you that cosine of 41 degrees is just this number. And that's how far she is from the top of the building. And just a similar idea. We have a boat that's sailing, and he meant to go directly east. So we want to figure out how far south he'll have to go from this point over here to go directly east of the dock. So once again, label your three sides. Here's the hypotenuse, here's the adjacent leg, and here's the opposite leg. We want to know this distance here directly south, so let's call that x. I want to figure out what this distance is to the nearest mile. So which ratio should we use here? Well, we're looking for opposite, so we shouldn't use cosine. And we know the hypotenuse, so we shouldn't use tangent, so we got to use sine. So sine of 27 degrees is opposite over hypotenuse. That would be x over 20. Sorry, x over 120. So x is 120 times the sine of 27. You just put that expression in the calculator. 120 times sine of 27. Oops. That gives us 54.47 about. And we want to round to the nearest mile, so it's traveled about 54 miles directly south. Now we can calculate the values of sine, cosine for any of these angles here, from 0 to 90 degrees. And an easy way to do that is to use the graphing function on the calculator, so we can get a table. So in this case, we want to fill in the table of values for dividing sine and cosine. So we're dividing sine of some angle by the cosine of the same angle. So to do that, go to y equals on the calculator. Instead of theta, we're going to use x. So sine of x divided by cosine of x. And if you press second graph, you'll see the table of values here. I want to start at 0 and go by tens, so I'm going to change my table. To do that, press second and window. This one says we want to start the table at 0, but we want our delta, our change, to be 10. We want to go by tens. So second graph. And here are the values that we're going to fill in that third row. And for 90, notice we get an error. Why do we get an error there? Well, we're dividing 1 and 0, so that's undefined. Now I want us to do the same idea for the tangents, tangent ratio. Let's fill those in and see what happens. So I'm going to put that in the second row here. Tangent of x. Second graph. And what do you notice about these two columns? They are identical. Why does that happen? Is that coincidence? Well, let's think about it. What's the relationship between these three ratios, sine, cosine, and tangent? Well, we know sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So we can write that ratio like this. And we know that dividing is the same as multiplying by the reciprocal. And here, these hypotenuses are going to cancel. So we're left with opposite over adjacent. And what's opposite over adjacent? That's tangent. So this shows us why when we evaluate tangent for 0 and 90, why we get 0, because 0 divided by 1, and undefined, because that would be 1 divided by 0. So this leads us into another application, is when we're talking about angles of depression and elevation. So how would you describe these two different types of angles? How would you define them? Well, in each case, you're talking about and figuring out the angle, or looking at the angle, between a horizontal line, horizontal to the Earth's surface, and the line of sight where the person's looking. So an angle of elevation is when you're looking above that horizontal line. And an angle of depression is when you're looking below a horizontal line. That's the difference. Now, how are they related to each other? What's special about them? Well, they're going to be congruent. These horizontals are parallel, So those are alternate interior angles formed by parallel lines. So they have to be congruent. So they're equal in measure. It's a very useful property. So now let's look at an application of these angles. It's very important that you can interpret the information given in a problem and draw a picture. So here we have Scott. His eye level is 1.5 meters above the ground, 30 feet from this tree. The angle of elevation from his eyesight to this bird is 36 degrees. How far above the ground is the bird? So first, I'd like you to draw this picture and label it appropriately with our measurements so that we can start this using trigonometry. This is probably the most important step here. So try to do this, and then I'll show you my solution. So here's how I labeled the picture. Here, we have this distance is 1.5, and this one is 30. And from his eye, the angle of elevation, so this angle above the horizontal, is 36 degrees. So we're looking for the distance from the bird to the ground. So to do that, we got to figure out this distance BC, and then add it to this distance from the eye to the ground. So first we got to figure out what's BC. To do that, we can use trigonometry. We have adjacent, opposite of that 36, and hypotenuse. And so which of the ratios are we going to use? Well, we're looking for opposite, and we know the adjacent length, so we're going to use tangent. So tangent of 36 is opposite over adjacent. Opposite is x, adjacent is 30. Multiply both sides by 30, and put that in the calculator, and you get 27.796. Now it doesn't say where to round to. Let's round to the nearest tenth. And when we add that to our 1.5 meters, right, the distance from his eyesight to the ground, we get a total of about 23.3 meters. So that's how far off the ground the bird is. Now, the angle that you're looking at isn't always going to be in the bottom left-hand corner of your diagram. So once again, in example 6, I'd like you to read the problem, draw a diagram that will help us solve the problem, and then I'll show you my picture. So here's my diagram. And here, notice the angle of depression is up here in the top right-hand corner. Still the same idea to solve it, though. So here's our angle. And let's see. So we have adjacent is up here. Opposite is over here. And hypotenuse here. And how we get 17.8? Well, the building's 16 meters tall. Add that 1.8 meters, 17.8. And so we're looking for this distance, x, right, from, what's his name, from John's friend, and between John's friend and the building. So we're looking for adjacent. So we're not going to use sine. And we know the opposite. So we're going to use tangent here. So tangent is opposite over adjacent, which is 17.8 over x. Switch the extremes here. So x is just 17.8 divided by tangent of 40 degrees. Think about that as proportion. And you evaluate that, and you get about 21.2 meters. In this lesson, we learned how to find unknown sides of right triangles using trigonometry. Thank you for watching this video.